So we ended our last lecture talking about the first satellite, Sputnik, and the American response, and the Explorer 1. And in the early days, there were several satellites that were launched, and this time they started the first interplanetary missions, flyby of the moon. Okay, but the goal was really to put humans in space as well, not because again this was part of the competition between the Soviet Union and the United States. At that time, there was a tremendous amount of politics involved in all of this. Both nations were trying to expand their spheres of influence in the world, and they wanted to make themselves look much stronger than the competitors so that other nations would ally with them. But still, the United States under Eisenhower wasn't really wanting to have a military presence in space. They wanted to show our technological prowess rather than that it was just simply a military conquest. And so they created NASA. And so NASA launched some of the first satellites to other worlds. The satellite towards spacecraft that flew past Venus, more spacecraft that flew past the moon. We also sent our first space traveler up, and that was Sam, the rhesus monkey. There he is sitting in his spacesuit looking all thrilled. And so now the difference is that we did not send our monkey up until we could bring the monkey back safely. So the Soviets sent Leica, the dog, up, and then the dog died. We brought Sam up, and Sam came back perfectly fine. Sam was shot upwards, not into orbit, but into a suborbital flight, and only went about 63 miles. So it's 100 kilometers. So that's just past the von Karman line that we talked about last week. And so that barely put him into space, but he came back safely. And they were still working on the details of how to come back from orbit. Because coming back from orbit, you're going a lot faster, and so you have to build a heat shield onto the rocket to protect it. Just barely going up to past the von Karman line, stopping and falling back, there's not nearly as much atmospheric heating, and so that was much more manageable. Well, in the meantime, Soviet Union wasn't sitting still. So they took another modified R-7 rocket, and on top of it was this bathysphere-looking structure right here. Inside of that was Yuri Gagarin. So in 1961, Soviet Union launched the first human into space. And Gagarin made orbits of the Earth and then came back to Russia. So he made the first orbit to the Earth. Now, actually, they didn't have a good way of landing him at the time. So the plan was to land back in the Soviet Union so that no one could see any failures that happened. But they didn't have a good way of softly landing him. So he actually jettisoned. He bailed out as the spacecraft was coming down. The spacecraft made a pretty hard landing that would have killed him had he stayed on board. And he came down by parachute nearby. That they didn't actually tell people that's how they were landing him at first, and so there's always been some question about giving him credit for the first takeoff and landing. He definitely was the first human to make it into space. Well, we responded by putting a chimpanzee up. Okay, so we had a spacecraft that was going to carry humans. This was we call the Mercury program. We had an extensive program to select some of the best pilots, and so they made it open to everybody. But the top pilots at the time were considered primarily the military test pilots. And so that was the main source of people, though technically it was open to not just military pilots, but anybody that was a top aviator. And the spacecraft was called Mercury and was a tiny little thing. I actually had a chance to sit in a capsule, a training capsule at one point, and it is tiny. You have to fold yourself in to fit into it. And so they had very stringent requirements for the astronauts. They had to be physically extremely healthy because they had no idea just what going into space would be like on the human body. And they had to be a specific size. They could not be too short. They could not be too tall. And they actually had to be shorter than the average American in order to fit into the capsule and fit into the space suit. And so they did have the very stringent requirements. And in the meantime, as they were testing the spacecraft, before they sent a human up, they wanted to send non-human, and so that was Ham the chimpanzee. And so he was launched up from Cape Canaveral and landed in the Atlantic Ocean. So it just went up and then back down. And they fished him out on the deck of a ship, and he was not real happy about the whole trip. He actually bit the handlers, I think. So anyway, the Mercury capsule was a very small little thing, barely big enough to put a human in there with electronics and the other sort of avionics you need to control the thing, a little bit of fuel to reaction jets to turn it back and forth, and then a heat shield on the back end of it that would protect it to go backwards into the atmosphere, and the hot gases of the air would build up on the back end and then boil away. The heat shield is called an ablative heat shield. It actually heated up and boiled away and carried the heat away that way. To slow it down in orbit so it falls back to Earth, they just strapped a rocket pack to the back end of the heat shield. And so the retro rockets would fire and slow down the spacecraft. Now, this tower on top was actually jettisoned after launch. The idea of that tower was it would yank the capsule off of the top of the rocket in case the rocket exploded during launch. Now, that actually was a real concern because these rockets typically did explode, so now to put them into orbit, they needed to use a large Atlas missile. The Atlas missile was a very flimsy sort of rocket, and they had a bad tendency of blowing up when you tried to launch them. So they were trying to work out all the details there, but NASA was under political pressure to get somebody up, and so they decided to go ahead with the same rocket they used for the chimpanzee. That's a Redstone missile. This is von Braun's missile. And so the Redstone missile would launch them, but it did not have the ability to put it into orbit, so it just tossed them up a ways, a suborbital flight that fell back down into the Atlantic Ocean. And so that was the very first mission. And so, again, this is a close-up of the side. You can see the person here next to the capsule right here. And give you an idea, and the crew compartment is just that little piece right there. So you can see how they have to squeeze in there. And there's the heat shield, and they splash down in the ocean. Now, this is different than the Soviet strategy because that means anybody can sail up to where they splash down. But they thought the splashing down to the ocean would be a better option than just hard landing somewhere on land. Also, the ocean is a much bigger target, and so they were having trouble actually targeting exactly where to land. And so this way, you can say the Atlantic Ocean have ships out there, and if you are 50 or 100 miles, off of your landing site, then you're still in the ocean. First American in space was Alan Shepard, other than Sam and the monkey and the chimpanzee. So Sam and Ham, I mean, they were first, but Alan Shepard, first human, May of 1961. So not that long after Gagarin, but Gagarin was first. Now, Gagarin made a complete orbit of the Earth. This was just up and down, so it was not a complete orbit. And so the spacecraft was called Freedom 7, and there it is launching from Cape Canaveral. This was very, it was televised, everybody was watching, everybody was excited about this, but they were also worried because these rockets tended to explode. And so they actually had rescue vessels all over the place in case it went off out of control, and then he landed someplace other than what they expected. But the flight went perfectly. Afterwards, he saw the president, and was awarded medals and declared a national hero. Now, the second mission didn't go as smoothly. Second mission, a fellow like Gus Grissom launched, and the spacecraft did a repeat of what Shepard did, but when it splashed down, the hatch popped open and it sank. And so they had this huge argument about why the spacecraft sank. And it turns out that comes back later in the story with Grissom. But the third mission was an outstanding success. And that was with the new Atlas rocket. The astronaut was John Glenn. And so Glenn launched into orbit around the Earth. And now notice a couple things about this picture I want you to notice, and that is that you see he's in a spacesuit and he's carrying something. What happens is that before they launch, they actually close the visor on the spacecraft on the spacesuit, and he breathes pure oxygen in the atmosphere. Nitrogen is heavy. It's it's like a major portion of the atmosphere, almost 80% of the atmosphere. And nitrogen didn't do anything for your body. And so they figured all you really need to breathe is oxygen. So when they launched, they used a pure oxygen environment. So what they did was they quickly dropped the pressure down to about 1/4 of an atmospheric pressure. So that means you're actually breathing about the same amount of oxygen for each breath. It's just you don't have the nitrogen in there too. But when you quickly drop pressure like that, if you've got nitrogen in your blood, it comes out of solution as little bubbles throughout your body, and that's the bends, and that can actually kill you or incapacitate you. And that would actually be very bad for an astronaut, that it happened to them in the capsule and you can't get any help. And so the idea was they'd purge their body of nitrogen by breathing pure oxygen in the spacesuit, and then they'd launch, and then quickly the pressure would drop. Okay. Shortly after John Glenn, at a press conference at Rice University, President Kennedy makes a announcement, a fantastic speech. I recommend you go watch the speech on YouTube somewhere. It's a fantastic speech. This speech is his speech that tells the nation that we are going to go to the moon. And that's going to be the new goal. That's what he's telling NASA to do, is go to the moon. And of course the NASA engineers are both going, yay, fantastic, and oh my gosh. Because all they had done so far is make one orbit of the Earth, and he's saying, well, we actually want you to go all the way to the moon and come back, and you're going to have to build a brand new rocket, develop new technologies that don't exist yet, and by the way, you're probably going to need new materials you have to invent in order to do all that. And this rocket's going to come back so fast, it's going to hit the atmosphere much faster than the orbital flights. You had to develop a new way of getting the heat to dissipate. Otherwise, your rocket's going to burn up, and your rocket's got to carry everything it needs to get to the moon, live, get back, and land. And so this new goal of going to the moon was this huge endeavor. And NASA was going to have to massively expand. So they were building a brand new facility to handle the manned missions. They actually took over the later Mercury and the Gemini missions, which came later, but that was being built right near Houston, on some land originally owned by Humble Oil Company. For political reasons, they could not just give it to NASA, so they gave it to Rice University, which leased it to NASA. In fact, technically, the Johnson Space Center is still owned by Rice University and leased to NASA. And which is why if you actually go there, the buildings look like a college campus, because that's basically what it is. But that's where we're going to go from here. Let's talk about the missions to the moon.